All right. Hello, everyone, and welcome to the second edition of our Meet the Engineer series of events. My name is Dr. Toby Elushakin, and I will be your host for this evening. This event is an opportunity for young students, school leavers, degree holders, and anyone else really, to really understand more about engineering, both in terms of the work itself and in terms of the personal experiences. We've already had one of these, and the recording is available online on the IET website. We also plan to have more of these in the future where other people, engineers, can come and talk about their work and their journey. Before we begin with the presentations, we've got a few house rules to run through. Firstly, this event is being recorded, so those who are unable to attend this event live and those who are looking to revisit the event in the future can access it. The link to the CPD certificates for this event will be posted in the chat very soon. We've also got a survey for you to fill afterwards, and this will also be included in the chat. Please use the Q&A function to prepare your questions to the speakers rather than using the chat. Please use the Q&A functions. The webinar should take between 45 minutes and 1 hour, and we expect and will try to keep to time. So the agenda is as follows. We've got the event start and introduction, then we'll have our first speaker, Julio, followed by a question and answer session, and then our second speaker, Martin, followed by a question and answer session. Our first speaker, Julio Perez Olvera, is an electrical and mechanical engineer with a PhD in electrical power systems. And our second speaker, Martin Halligan, is a chartered railway engineering manager. They'll both be speaking to us about their journeys so far and their experiences as engineers. Julio will go first, like I mentioned, and then Martin will be speaking second. Without further ado, I would like to introduce our first speaker, Julio Perez Olvera. Julio, take it away.
Hi, everyone, and hi, Toby. Thank you for the introduction, and thanks, everyone, for joining us in this webinar. Like Toby said, I'm an electrical and mechanical engineer, and I'll be presenting today what has been my journey so far in the engineering world, and I hope that gives you an idea of one of the many paths that you can take in engineering. I'm going to share my screen now then. Can you see my screen now, Toby?
Yes, yes.
Okay. So I started my journey in engineering in 2014 as a mechanical and electrical engineer. And since I was studying engineering, I was very much interested in renewable energy, especially wind and solar PV. And also I was quite interested in electrical systems, power electronics and industrial power systems. And I was thrilled by the idea of using natural resources to power our everyday needs. So after I graduated from my degree, I did an internship at a company called Abengoa, which is a developer of wind farms and solar PV plants. I was in the proposals department, so we would basically prepare projects and bid for projects for for the construction of new new power plants. And I realized that I really wanted to go deep into what was the background of renewable energy, and what were the building blocks of of all these installations. So I decided to pursue a master's, an MSc at the University of Birmingham, which was focused on power systems, which I consider the building block for any major project in renewables, whether it be solar PV or wind farms or hydro, anything. You have to know what the basic power system does and how to do it. So I did my master's to get a bit more knowledge about how the systems work, how they operate. And my final project was focused on distribution networks and how to integrate new technologies like solar PV or electric vehicles. And I got really interested in this part of the power system of the network, and I decided to do a research and do more formally a PhD in power systems with a focus on distribution networks and how we can integrate all these low carbon technologies into these networks. And while I was doing my PhD, I worked for about a year as a technical officer for a non-profit called Repower in London. And then after graduation, I worked as a power system consultant for ABB. And at the moment, I'm working as a distribution system planner for SSEN. And I'm gonna talk about more in detail, about a couple of these stages. So during my PhD, I focused on analyzing or investigating different ways in which we can integrate these low carbon technologies, which is essentially anything from electric vehicles to heat pumps, rooftop solar PV, into distribution networks. And for those who are not familiar with power systems or distribution networks, I have put a diagram, a very high level diagram on the right. And basically, a distribution network is the last part of the electricity network. This is where all the customers are connected to, all the houses and all the shops, everything. And that's also where some of the major changes are happening, when everyone will be getting electric vehicles, or when everyone has rooftop solar PV on their houses. So there'll be a lot of changes in distribution networks. So during my PhD, I focus on building a more realistic network models, or also sometimes called digital twins of these networks. And I investigated what are the typical impacts that these technologies can have on distribution networks, for example, voltage, power losses, everything that has to do with how variable the power is in these networks, and how much demand can we supply, etc. And I also focused on proposing new methods of managing the power in these networks, and specifically there's a strategy called active network management, in which you can either control the specific generators or loads, or even the network itself, so that you can find the best time to inject power into the network, or the best time to have some power flowing in in certain directions, either upstream into like the transmission network, or downstream into the customers. I also participated in some innovation projects led by industry, by distribution network operators, and during these projects, I got a chance to like analyze like data from like several real like secondary substations in the southwest of England, which was very interesting because it would give you that like a sense of like these are like some of the models that I've been developing, and now this is like some more realistic data on what like the actual substations are seeing. So it was like a good validation of like what I was doing during the project in my PhD. A lot of what I was doing involved like MATLAB and Python programming, which I actually like enjoyed a lot. And also like a part of it was power system software analysis. When I was a technical officer at Power in London, what we did was we conducted feasibility studies for solar PV installations, and these were like aimed at community energy projects in London. So basically like local schools or housing estates in some of the boroughs here in London. And my role was to develop 3D models of the buildings so that we could estimate what was the suitability of these buildings for solar PV. How much area like do we have in the roofs? If the orientation is good, and if there's any like shading from any neighboring buildings or from any trees, things like this. And at the end, what we ended up with is like a capacity that we could install in some of these buildings. And I also analyzed the energy consumption data from these buildings so that we could estimate how much of the energy that would be produced by these rooftop solar installations would be used by the building, and how much of the energy would be sold back to the grid, which that's essentially like it's those are two of the inputs that we used to estimate the financial viability of the project. So it was a very like interesting role, because I would see like the actual like impact into the communities, how they would organize themselves to like for example, put the money together to fund these installations, and then also like use like some of the local like networks to get young people like some professional experience, either installing the solar PV panels or like at different stages of the project. So it was like a very nice and very good experience. And then while I was working at ABB, I was in the power consulting department, and we mainly work with clients, providing technical advice and also reports and solutions to some of the problems that they sometimes faced in their electrical infrastructure. One example of this is offshore wind farms. So we did studies of like the grid compliance of the offshore wind farms that are proposed to be developed. So for example, if you want to develop a new offshore wind farm or a wind farm anywhere, one of the first steps is to do these compliance studies, so that the national grid, for example, knows that this wind farm is not going to affect the voltage at the point of connection, or that is not going to affect the frequency, or that it has enough reactive power compensation. So those are the things that we would do in our team. We would analyze like the power losses of the wind farm as a whole, and we'll try to optimize like the installation of compensating equipment and things like this. As part of my role, I also develop Python scripts so that we could automate like these studies, and we could run like a lot of simulations in the background, so that we wouldn't have to like be like clicking every time we want to run, for example, a simulation with a different set point or with a different setting. So we would just like have something predefined and then let it run in the background and then come back and analyze the results later on. I use the power system software like Power Factory and PSCAD. And in the diagram on the right, you can see that whereas like in my PhD, I focus on the like distribution network, which is like the part at the bottom. During my work with ABB, I focused on the upstream part, which is like the power generation stations. And in this case, offshore wind farms are like directly connected to transmission networks. So it's like a different philosophy that you have to use like in this case. So it was quite a useful experience, and I learned like another like part of the power system. Now, and currently my role is a distribution system planner at SSEN, and SSEN is it's what we call a distribution network operator, or DNO. And as a DNO, we own and maintain the electrical infrastructure that is needed to supply electricity to our customers, which are like about 4 million. So we supply the central South England and also the north of Scotland and the islands there. And our aim is to provide a safe and a reliable energy supply. And we're essentially like the intermediaries between the energy suppliers and the generators. And in particular, I work in the innovation department, or we also call it future networks. And what we do in this department is we look at a few years into the future, and then we try to estimate how the generation and demand would look like in the future. And we essentially have to ensure that the network can cope with any like future demand or any changes, any like new technologies that come into the network. For example, electric vehicles, heat pumps, rooftop solar PV. And then we propose and we develop projects where we can test new ideas. For example, projects where we can test how we can use the network more efficiently, and how can we integrate more renewables, while also keeping a reliable supply. And a lot of these projects are like in combination with multiple like stakeholders, whether from industry, like, or from the community. So there are like sometimes like big projects spanning like several years, and we try to test like these ideas so that we can then adopt ideas like that are already like proven, or don't adopt those ideas that like didn't seem to be like cost effective, for example. And at the moment, the project I'm working on is called Local Energy Oxfordshire, and or Project Leo. And what we do in this project is we're essentially carrying out trials of what we call flexibility markets. And these trials will enable SSEN to transition from what we call a network operator into a system operator. And that essentially means that we will take a more active role in managing these networks, and will enable more market-based services. And by being like flexible, we mean that you can make some changes in the way that you consume or you generate electricity, so that the infrastructure can be used more efficiently. So, for example, like if we observe like a very large demand of electricity during the evening when everyone comes home, then we can ask some of the customers, for example, if they can shift charging their electric vehicle, for example, if they can charge it at midnight rather than like in the evening. And that's like that flexibility which the customers can have, that can be traded. Like so that's essentially like what we're trialing now in this like in the flexibility markets. And to enable flexibility markets, part of my role is to develop network models for the Oxfordshire area, and these are also like sometimes called digital twins, because we take like the network components, like all the cables, transformers, and we model them in power system software, so that we can test several scenarios of what would happen if we do this, what would happen if we do that. And then the idea is that like at some point we would be able to say where would a constraint in the network would occur, and how can we procure this flexibility from customers to alleviate that constraint. And to build those models, we essentially have to integrate several different sources of data, like geographical data, network data, customer connectivity data, because we need to know where each customer is connected to and how it affects the network. And we also need the forecasting models for the load and the generation. And we need to know, for example, how much load are we expecting in a week or a month, and the same with generation. Now, as part of this project, we have to deal with multiple stakeholders and project partners. And this ranges from consultants, contractors, also our colleagues in the business as usual operation of the network. We have to like try to replicate as closely as possible the actual operation of the network in our project. And of course, we also have the market participants. And I think that's all I wanted to talk about. So I think now, if you have any questions about any of the slides, you can just pop them in the chat, and I'll try to answer as best I can.
Thank you very much, Julio. That seems, to be honest, like a very full career already. So well done on what you've achieved so far, and thank you for taking us through that journey.
Sure.
Just to start the question and answer session, for me, I've got a question just based on my own experience. Why, first of all, did you decide to go for a PhD? What was the motivation for that?
For a PhD, I think the main motivation was that at the moment, when I finished my master's, and when I did my final project on like distribution networks and all these like low carbon technologies, the interest from the industry, for example, was not very high. So like from a quick like survey, like in like the industry, like these were still concepts that were considered to be like a few years into the future. So like that, and like not everyone would have, for example, a rooftop solar PV installation or an electric vehicle. So it wasn't as worrying as it is, for example, now, that everyone now talks about like, oh, like now we have to prepare the networks. So I thought that the best way to get like a better understanding of like how the future might look like would be by doing research. Like, because sometimes like, or majority of the times, like in academia, like you look at a problem, or you look at a particular sector like a few years ahead. Like you usually look about 5-10 years ahead. So I think that was like the main motivation, and yeah, like I did like found like what I was looking for.
Okay, that's good. Another question, just based on your presentation, you mentioned that SSEN, originally the role seems to be more like a middleman, but now you're looking to take a more active role as a system operator. What does that mean in layman's terms, essentially, just for us that aren't in that industry to understand?
Yeah. So essentially, like right now, as it stands, SSEN is responsible for like maintaining the network and making sure that it works. So making sure that everyone has like a reliable electricity supply. But the main issue is that whatever cost we have, like for the network, so if we need to replace cables or transformers or anything like that, it like everything that we spend has to go through the bill. So everything that we spend goes to the consumer's bills, and also like a lot of the work that goes into like upgrading like cables or transformers is only for very specific periods of time. So for example, like we need to ensure that our transformer is can operate well on Christmas Day, or when we have like the very, very high peak, when everyone is at home and they turn on their TV. That's like the limit of where the infrastructure has to be. So we have to be able to supply at that limit. But that means that the rest of the time, the network is essentially not being used at its full capacity. So in a DSO world, like when I mean that we will try to be more take a more active role, is essentially trying to use the network more efficiently. So not build or not upgrade the infrastructure to sustain just the 4 or 5 peaks that happen during the year, but trying to like handle it more in real time, for example.
All right, thank you very much. We've got one more question. If you could take this very quickly, so Martin can come and give his presentation. Someone has asked, and I'm assuming this person is referring to a person. They've asked, how would a person get involved with your company who doesn't have an engineering degree but has an eng tech?
Well, we actually have like a lot of like routes into like a SSEN. One of them is like we have like a graduate scheme, which is like a 2-year program in which you can like rotate through like several areas, several departments. We also have like an apprenticeship, either like engineering or data, anything. And the other one is like a direct role. So I guess it would depend on the level of experience, but I think like we definitely have like a wide range of like of entry points, like from graduate to like people with more professional experience.
All right. We've got one question, but then I would want to actually save this for after Martin's presentation, and then maybe ask both of you. I think it's a very pertinent question. But at the moment, we'll just move to Martin.
I'll stop sharing that.
Yeah, thank you. All right, Martin Halligan. Thank you and welcome. Thank you very much for joining us and for deciding to share your experiences. I'll hand over the floor to you now. Please go ahead.
Brilliant. Thank you very much, Toby. Right, so, fingers crossed we've got this working. Screen sharing okay?
Yes, good.
Perfect. All right. Thank you very much. Well, hello, everybody. So, yep, my name is Martin Halligan. I'm a chartered engineer working in the railway industry. So, I guess sort of first off, big question, introduction. Well, what is my engineering job? What do I do? To wrap it up, I solve problems. That sort of really is my career in a nutshell. But that doesn't really help explain actually what I do. So, as part of that, so at present, I'm a chartered railway engineering manager. And to get to the point where I have now, sort of I've spent 8 years since graduating from university doing different jobs on the railway around the world, sort of working across sort of all sorts of systems, but it does still kind of relate back to what I studied, and I'll go into that later. And so my sort of core areas of competence and usually focus with things are around the telecoms, control systems and signaling systems that go to make a railway functional and allow it all to work. So, right, that's fine, but what does that all mean? What do I actually sort of do here? So, since starting out my career, I've produced electrical design diagrams. I've designed cooling systems and lighting systems to go in on London Underground. I've written software to support data analytics. So, that was part of a predict and prevent program where we actually collected asset data from our trains and started applying algorithms on it, machine learning and visualization technology to essentially try and predict failures before they actually happened and sort of enable our maintenance teams to do maintenance before things actually broke. One thing that I'd never really figured when I was at university and sort of spend a lot of my time doing is I use Excel a lot. So this goes through whether it's helping sort of actually capture information through requirements or whether I'm sort of actually trying to put calculations together. One proficiency that I picked up at uni and has helped me unbelievably so through everything is actually being able to use Excel. So mostly nowadays though, so that's sort of what I've done in the past, that was the past tense, but nowadays I tend to write sort of more specifications that actually go into major infrastructure contracts. So one thing I'm working on at the moment is with High Speed 2, and I'm actually sort of helping to define the contract boundaries that exist between all the different contractors that will come to deliver that railway. So for an example, there's a signaling contract, and they will deliver signaling, it says on the tin, but we'll then also have another contract, which is the telecoms contract. And what we need to do by working with HS2 is to ensure that the way that we are telling all of these contractors and what they're delivering and the detailed aspects of the functions they'll deliver, like how many trains you want to run per hour. We need to make sure that actually once they deliver all of their bits, it glues together and actually makes something that does work, because it can actually result that if you just ask all your contractors to deliver individual bits and you've never actually looked at how it will connect together, that's exactly what you'll get, a whole bunch of individual bits that don't actually work. So that's what I end up doing really a lot of the time now. So to do that, I provide consulting on engineering management, and typically this actually comes through a substream of engineering management of systems engineering. And so for the past few years, I've done a lot of things around requirements management. So that's actually taking what starts off as a simple statement, which could be from a political body, it could be from actually a client organization like Network Rail, who say, I want level access on trains. Okay, that's great. That doesn't actually help you start to derive an engineering solution, because you need to really take a step back and think what is in your scope and what isn't in your scope. And so by doing requirements management, we can start helping illustrate how we get there. So that could be the track shall be at a certain height, the platform shall be at a certain height. And by achieving all those individual requirements and managing them with our contractors, we actually deliver the end achieved requirement that was needed, which was level access platforms. Another thing that I've been working quite extensively in is configuration management. So this is all about actually understanding what is at the final delivery of a railway and how that comes together, and being able to manage the changes to those items. So if we were to do maintenance or sort of intervening maintenance or emergency situations, or even need to, and believe me, it might happen with your home router, it can happen on signaling systems as well, turn it off and turn it on again, we'll need to know sort of what actually happens on that configuration to do that, to make sure that we don't introduce other errors by, you know, sort of tweaking one little thing over in this corner and not recognizing what the impact could be to the larger system over here. And the final thing is systems integration, which is what I touched on before with my role on HS2, where it's all about actually ensuring that all the different discrete elements that will go to deliver a railway are sort of joined together to derive a function that ultimately makes trains run and actually allows people to get on the trains as well. So you need to factor that in. So how have I got to doing that? What have I worked on? So as I've mentioned at the moment, my time is focused quite primarily on HS2. In the past, I've worked on other major things around Crossrail. So for Crossrail, I helped on the maintenance team deliver what was called the infrastructure monitoring vehicle. There'll be a picture later, but this is basically a train that has a whole bunch of sensors on it to detect whether it's sort of like, it uses LiDAR coming out the front. We've got ultrasonic probes that run in tandem with the wheels. And the idea of all of this is we have all these sensors that combine together on the vehicle that can record all of this and do data analysis on previous recordings. And what you can start to see over time is track degradation as trains roll over it. And that actually allows the maintenance teams and track maintenance teams to plan their work, to intervene if suddenly a rail cracks. And normally what you see when a rail cracks, it doesn't quite normally just crack like that. As things wear on with metal, you might start having deformities in the middle of the rail, and these ultrasonics pick that up, bring it back to maintainers, and they can spot defects over time that allow them to go out and fix the rail before it actually becomes a problem. Other things I've also been working on is sort of helping develop new safety cases around new signaling systems that are being deployed in the United States. So they're looking at rolling out brand new signaling technology that uses GPS, for example, for them to be able to accurately detect where a train is. And we've been helping, or I've been helping sort of actually go through their safety case assessments, what their safety and reliability statistics are, because one key thing that I look at in my role as well is reliability, availability, maintainability, and safety. Because ultimately it's no good having a railway that just falls off the track all the time. We need to make sure that we're actually traveling people in a safe environment. So to do that, we do that analysis work. And I was doing that to help this new signaling system in the US. I won't go any more into what signaling actually is yet, though, because that's in its own right a whole other topic to go into. Now this picture on the side, I just thought I'd sort of show a few things from my past. I've actually realized when trying to put this together that I really do not take enough pictures of what I've done in my time. What this is a few years ago actually, so if anybody ever gets to visit Crossrail once it opens and go to Canary Wharf Station, you'll go down, and I mean, you won't see this because it'll be finished being built, but this is one of the sites that I went out to as part of a project to investigate where some equipment was going. And actually on the left hand side there is all behind that is actually the tunnel that was still being constructed at the time, but this is actually the platform itself. So that's one thing I did. Right, so how did I actually get to doing what I'm doing today, if that's what I do? So I studied electronic engineering at the University of Exeter, and as I'll show on a timeline slide in the summary, I hadn't quite planned to do that, but that's where I actually ended up. And so I spent 4 years studying for my master's, got towards the end of my master's, and then I thought, well, I don't really know what to do. And truthfully, I didn't know what to do following my further education. I applied for various graduate schemes because at my university, we sort of had, you know, the typical sort of careers outlook. There's this scheme, that scheme, you can go there, you can do this. At the same time, I also thought about sort of going for a PhD within the university as well. So there's a couple of offers there. And ultimately, I chose where I did because I decided to join Transport for London under their electrical engineering graduate scheme. And to me, the main factor for that was actually, I'd grown up in London, I'd been around transport. I sort of knew that, you know, Transport for London was quite big, London Underground was big, there's lots going on. And I thought that could be quite an exciting way to start a career in electrical engineering. And one thing that I had noted at the time, and it never crossed my mind really, but was actually that the Transport for London graduate scheme when I applied was a, I don't know if it still is, but it was called what was called an IET accredited graduate scheme. And inside of that, it actually meant that it complies to developing engineers along to the UK spec. So it's not only IET, but IMechE is accredited as well. And that actually, I'd never really, as I said, thought about the importance of it. But looking back on it now, I can actually realise that by the schemes being accredited in that way, it does really help development through the UK spec. And for anyone not aware what that is, the UK spec is a set of competencies that you demonstrate how you've achieved what they are asking for through years of experience post-graduating that actually allows you to apply for chartership. So this was a real booster to me, and in hindsight, I'm very glad that it was an accredited scheme, because a lot of my experiences from the graduate scheme went to actually go my chartership application. And that's just a picture of me wandering about on some track. Now, things that I did when I was on the graduate scheme. So I designed electrical disconnection systems as part of a major upgrade program. I worked in sort of strategy and service development, modeling future upgrades. So this was sort of stuff that still even today hasn't actually gone out as a major project, but I helped sort of work out what could happen if London were to sort of population shift around and see that we'd need to do different train services on different lines to actually accommodate how London would develop in a different way. And then I also visited a whole bunch of disused underground stations to inspect and install test equipment, because for anyone wondering what happens around some of these stations that no longer exist, that's actually what we use them for. And I competed in what was called the IMechE Railway Challenge. So just on the side there, so one bit of my graduate scheme, not necessarily engineering related, but I drove a train. But for the IMechE Railway Challenge, which was we had to design, build, and run our own vehicle, actually under competition standard with the IMechE. I ended up driving a much smaller do-it-yourself train that we built together. And that was in tandem with graduates from mechanical disciplines alongside ourselves as well. And the final picture, for anyone that might sort of know London or London Underground, there's, if you ever look at the map, there's a station called Charing Cross, and that no longer exists on the Jubilee line, but it did at one point exist on the Jubilee line. And that, because of that, there's platforms that are inaccessible to the public below ground. And inside there is actually where a lot of suppliers will go and test their equipment. It could be brand new technologies to put on the metro in a real underground environment, but just not open to the public. So on this picture, for example, it's unfortunately not great resolution, apologies, but you can see sort of little white dots around the roof there. And what this was trialing is a brand new LED lighting system to obviously sort of enable a transition away from fluorescent bulbs to become more energy efficient around our escalators, and prove that we could still have good lighting around escalators for passenger safety, so everybody could still see everything. After London Underground, I then sort of moved to my company that I'm at the moment, which is SNC Lavalin Atkins, to broaden my experience in railways around the world. As a result, I helped work building on a new metro line out in Canada. I've worked on safety analysis, as I mentioned earlier, for a new signaling system on American railroads, and defining interfaces between different contracts delivering on high-speed data. So that really. One thing that I've also been doing as well is in volunteering with the IET, and I found that personally to be quite rewarding as time went on, and helping sort of share my own development and competence back to younger engineers wanting to start out in railway. And so at the moment, that's got me to the point that I'm now elected vice chair of the Railway Technical Network within the IET itself. But the pictures on the side here, so this again, a lot of my job has seen me going out to various different sites, which is quite fun to see things getting built, really. And so this is actually a station that's out in Ottawa in Canada. And this rather looking strange yellow rectangular blob at the bottom is actually sort of, this was the infrastructure monitoring vehicle that I mentioned earlier that I helped sort of Crossrail actually specify to get this built and sort of get this out in service, doing some good monitoring. So this is where I'll leave on the final slide. I'll open up to Q&A in a moment, but I just thought I'd talk through actually, well, okay, what is my development over time? How did I end up where I am? And so all the way back in 2008, I applied originally to study computer science. I wasn't really 100% sure what I was doing at that age, if I'm being honest. I took a year out trying to figure out if I actually wanted to go to university. I hadn't really got a handle on it. And during that time, computer science actually was cancelled as a course. So I then thought, well, okay, what's can I do? And the university reached out and said, well, you had a place secured, would like to honour it. Here's an alternative. And so I ended up sort of taking electronic engineering and computer science. Following that, actually realised that computer science wasn't quite my bag, or at least not how I understood it from it being taught there at the time. But I really gelled with electronic engineering. So then I stuck with that and still worked on sort of the electronics side. And then, as I mentioned, 2013, graduated and decided to go to London Underground. Graduate scheme lasted 2 years, and in that 2 years, sort of as indicated earlier, sort of moved around the business, did lots of different things, saw lots of different stuff, and then completed the graduate scheme and moved on to a predict and prevent team at London Underground. Then in 17, joined my current company. In 18, I spent that year working out in Canada with my company, and then also got my chartership at that point in time. In where we are now, so yep, vice chair of the technical network of the IET. And that's really it in a nutshell. I don't know if I've overrun, I'm sorry if I have ever slightly, but if anybody's got any questions I don't get around to answering just by the compressed time, my email is in the bottom left corner, so please do reach out and get in touch. Is there anything else you'd like to ask? That's me done. So.
Thank you very much, Martin. Thank you for sharing your journey through from applying to uni to where you are now. I'm quite grateful for that, because it gives a good idea for a cross section of people that may be in the audience. So from university students to people who are already graduates, people who are looking to apply for that chartership and what have you. So it does cover a broad range of things. So thank you very much for that. The first question that we have specifically for you is from the audience. What advice would you give to system engineers who are aspiring to become engineering managers? So how did you transition, I guess, from that technical aspect to a technical and managerial role, if you will?
Yeah, that's an interesting question. I think there's always an interesting divide where sort of you can fall into this trap of maybe thinking that you are either technical or managerial, and then I think sort of sometimes companies will orientate their development around that level of thinking, which it doesn't always work that way. I've met some sort of very technical people that are also still in the realms of management as well. Truthfully, it comes with competence over time and confidence. And the big bit of advice I can give for that, if you're looking at starting off doing systems engineering, is go in there and learn as much as you can. Just sort of wherever you end up working, or if you go on to further education beyond that, is explore everything, keep asking why, making sure that you can work with a company that will give you open to new experiences or try new things out. And the more that you try out, the more competent you'll become. And as you become more competent, you'll actually be more comfortable in leading others to sort of follow in similar development paths. And by nature of leading people, you would then actually naturally fall into a leadership managerial type thing. And then you'll start actually understanding a bit more how to manage those tasks. Now, there's other things to it as well. So one thing is, for example, looking at actually formally developing your project management skills around the Association of Project Management, and that gives you the academics to it. But very much, I think that's fine. But the important thing is actually having that leadership quality first and foremost, and the rest of it will all naturally start to slot in.
Thank you. I completely agree. I would say, building up that competence, I guess, within your field, and then from there developing the ability to actually lead others. And then also looking at that project management aspect of it is also quite important. I know that the APM is quite big within the UK, and they also really support in terms of development for students and people who want to move into project management, and that can also help to transition into managerial a managerial career in general. So yeah, thank you very much for that. There's someone here who would like to join the Railway Technical Network, and they're just asking how that can be done. If you could give it a short summary of how that can happen, essentially.
Yeah, sure. First thing would be to contact me ideally on the email in the bottom left. So that's it for the it's actually my IET volunteer address. But in general, yes. So we have underneath the technical network sort of two springs of it. So we've got the technical network mainly itself, which sort of requires perhaps a few years experience in a certain field to be able to form part of the main committee. I've only just sort of got into that committee myself. There is another element which springs out of it, which is a young professional side of it, where actually we have a group of young professionals, sort of early career people that are all obviously very excited to join. Sounds like you are as well. And we basically have ideas that we put together as a committee and talk it through with the young professionals. And actually the goal is to sort of get the young professionals to help us deliver on some of those things. So if you're keen, you're interested, you want to join, would love to hear from you. Please do email through.
Okay, and then a question for you and Julio, if Julio could put on his video, please.
Yeah, sorry.
But Martin, I'll ask you to go first, but it's a question for both of you. If you could just give quick answers. In your experience, how important is a placement in developing a career as an engineer? In your experience, how important is a placement?
Yeah, very interesting question. My answer might be slightly skewed by the fact that I didn't actually do a placement, but something that I haven't put on the screen is that prior to all of this, I worked in a supermarket for about 7-8 years alongside my education. And I think actually it's not necessarily a placement that's important, but having some experience of working world. And the reason for that is not only you demonstrating that you have worked somewhere before, but actually beyond that, I remember in a lot of my graduate interviews, it was, yeah, fine, you've worked, but actually it starts ticking your mind when you start thinking about explaining where you currently work and how things come together and applying your education to that. So when you do go to interviews, actually you're able to really talk about, you know, what might seem in my case it was working in a sort of supermarket around sort of all different departments, but actually applying sort of engineering thinking to what I was doing and understanding the business. And then that actually helped me really explain to future places where I was going, how I already had a bit of a grasp around that. So I definitely say work experience is key. Couldn't speak so much about whether it's definitely a placement, but I assume by logic to that, if you were in a placement in one company, that they might then obviously want you back as a graduate later on as well, because they already know you. But yeah, that's my thoughts on it.
All right, Julio, do you want to help us take on that question?
Yeah, I agree with Martin. And for example, like I also didn't have a placement, but I worked during my PhD, yeah, and I think it gives you like a different perspective, and it broadens like your view of like if you're doing something while you're studying. I think it can definitely give you like a more like a real world like perspective, especially like at the PhD level, when it tends to get really like technical. Like I think it's very good if you can get like a view of like what's actually like happening in industry and what's applicable in industry, what is it that the companies like care about. So I think, yeah, it's really good. And at least in SSCN, we've had like several like graduates coming in and working in the project. So I think they get like really good experience, like in terms of understanding like how this project like evolved like over like the years, the project, like how to like deal with like all the stakeholders, like what's a deliverable, like everything. So yeah, I do think it's important.
Okay, yeah, thank you very much. I agree with both of you actually on the importance of work experience. Doesn't necessarily have to be those official placements, but then, you know, having that experience and being able to be within that work environment or the world of work essentially, not only gives you, if even if it's in a technical capacity, not only gives you that technical know-how, but just I would say personally a bit of resilience on how to deal with the world of work when you actually finish uni and get into that. So thank you both for those answers. I've got a quick question for Julio. I believe this is tailored more towards your presentation. Someone says that, and I'm just trying to get this question correctly, there may be system power losses in the network So how much is the acceptable range of losses? I'm not familiar with electrical engineering
Yeah.
speak, but I don't know if you understand that.
I mean, normally, so losses is just you generate electricity in like offshore wind farms or like gas, but not all of that energy gets to the customer. So some of it is just lost in the network, in the cables as heat. And for distribution networks, it's around 5%, between 5 to 6%, like is the range that is acceptable. Yeah.
Okay. All right. Thank you
I hope
both.
that helps.
Yeah, I hope it did. Thank you both very much for taking the time to speak to us, to educate everyone on your career. Very last question, actually, someone has asked a question, and we'll just go ahead now. I think this is to Julio. So the power system software they use, are they open sourced? And is there any way a PhD student in clean energy can be involved with SSEN? If you could give us a 1 minute answer.
Open source, no. I mean, like, I haven't released them. I have them in my computer, but I guess I can think about like releasing it. But at the moment it's not. And then the second question, sure. Like, I mean, SSCN is like all the time like looking for new like engineers or new like recruits. Yeah, especially like in clean energy. Yeah, definitely. I would suggest you have a look at the careers website. Yeah.
All right. Sorry, let me see. Thank you. Thank you both very much. Thanks to our amazing speakers. Julio, Martin, really
Thank you,
grateful.
Toby.
I'm sure a lot of people have learned from you this evening. And to the audience, thank you all so much for joining us for this webinar. You can contact us for more information on how you can join the IET London Young Professionals team. Follow us on social media at IET YP London on Twitter, Instagram, IET Young Professionals on LinkedIn and on Facebook. As previously mentioned, there will be more of these events in the future, so please stay tuned and have a wonderful evening, everyone. Thank you.
Bye then.
Thank you.
Thank
Bye.
you. Bye.